Okay, the negative binomial distribution. This is similar to the geometric distribution in that we're looking at numbers of trials where we've got exactly two independent outcomes, and we want the number of trials needed to achieve a fixed number of successes R. So if X is the number of trials needed, then this is notation, so negative binomial, number of successes required, and P is constant probability of success. And it's essentially same as in the binomial distribution. There's exactly two, sorry, I need to put the word exactly in there, independent outcomes. So the conditions are the same as for the geometric distribution. So what I want to do is consider rolling a fair dice or a fair die repeatedly until a total of 3 sixes are rolled. So roll a fair die repeatedly until a total of 3 sixes. Are rolled. So X is negative binomial, R is 3, and the probability of rolling a 6 is 1/6. If you want to roll a total of 3 sixes, then that's going to require a minimum of 3 trials. So this particular negative binomial distribution, X has got to be greater than or equal to 3. In the geometric, we would just roll until the first success, so X is greater than or equal to 1. But Poisson and binomial distributions, then X can be 0, you can have no successes. So it's a different distribution. And what I want to look at is consider the probability that X is equal to 10. If you think about this, if X is equal to 10, that means that your third success or well, your third 6 will occur on the 10th roll. So we don't really mind where the other 2 6s occurred. We just know the third one is going to be on the 10th roll. And so in terms of probability theory, we can find the probability there are exactly 2 6s in the first 9 rolls. So we now have a fixed number of trials, 2 independent outcomes, success and failure, and we want to find the probability of there being 2 6s. And so this is binomial distribution. So exactly 2 6s. Yeah, the other thing I probably should have said is the negative binomial is an infinite series like geometric distribution, an infinite number of terms. Exactly 2 6s have been rolled. On previous 9 rolls. So this probability So exactly 2 6s in first 9 rows is going to be 9, 9 choose 2. The probability of getting a 6, which is 1 6 squared, and the probability of not getting a 6 to the power of 7. So this is a formula for the binomial distribution. If you're not sure about that, I can go over that separately with you, just let me know. But basically we've had a 6 and a 6 and not a 6 and not a 6 7 times. So you multiply those together, and this gives you the number of ways those 2 6s can occur in the first 9 trials. If you want to understand that a bit better, just, let me know and I'll go over it with you. So the probability that x equals 10 is equal to the probability of exactly 2 6s in the first 9 rows times by the probability of getting a 6 on the 10th row. So it is 9 choose 2, 1 6 squared, 5 6 to the power 7, and then I need to times that by 1 6. And so we now have 9 choose 2, 1 6 cubed, and then 5 6 to the power of 7. So similarly, the probability that x equals x, remember x is greater than or equal to 3, is going to be x minus 1 choose 2, 1 6 cubed, 5 6 to the power of x minus 3. So you'll have x minus 3 rolls that aren't a 6, 3 rolls that are a 6, and this is the number of combinations of 3 6s in x rolls. So you need to add up all of those probabilities. Sorry, it's the number of combinations of 2 6s in x minus 1 rolls here. And then you times that by 6 at the end. And so more generally, the probability that x equals x is equal to x minus 1 choose r minus 1 p to the r q to the x minus r. So this is where x is the number of attempts up to and including the arse success. So that is just an expansion of this one here. I've just replaced that 2 there with r minus 1 and the 3 with r. So that's in the formula book, so you can just rote learn it if you want to. I personally quite like being able to do this so that you've got 2 6s in the first 9 rolls, that's your binomial distribution, and then times by getting a 6 on that 10th roll. So it's 2 6s, first 9, and 1 6 on the 10th, which takes you to there. And if you understand that binomial formula, okay, I did quite a lot of work with that in my group, but I know I haven't done that with all of you, so if you need a little bit of help understanding that, then just let me know. And general formula is there, so if you just want to plug into it, feel free. It'd be nice if you understand this process here as well, but you don't need to.